Lecture 7. The previous one was actually lecture 6. This is not going to be on the exam.
Which, as I mentioned last time, on Tuesday, is under the Unit 2 material on Blackboard. So some of you already mentioned that they didn't find it. So it's under Unit 2 in Blackboard. I did find a couple mistakes on it this morning, so that I did upload a new version this morning. But anyway, it's under Unit 2. And again, like I said last time, it won't be on the exam next week. Next week's exam is lectures 1 through 6. I'm going through this even though it's on Unit 2 exam because I don't want to get behind, and I wanted the exams to be on Tuesday, so you had a weekend to prepare or rec on behalf of me. So anyway, and at the end of today's lecture, when everybody's here, hopefully, I'm going to go through the procedures which I use for my exams and also talk about the exams and things to do to get ready for it. So that'll be at the end of today. And to make sure that I have time for everything, I'm going to skip the, what's going on here? I'm going to skip the eye clickers. I know that's kind of sad and you're really disappointed, but we won't have to worry about the eye clickers today. Make sure we get everything done. Okay, this material comes from Chapter 7 in the anatomy book, and every good human anatomy book has a chapter on articulations. It's a very important subject. Articulations, we usually think as bendable joints, but in terms of anatomists, they don't necessarily have to move or be modal type connections. In other words, the term really means, as far as an anatomist is concerned, a connection between two bones. And you'll see some of them are far more modal than others. So the function of an articulation is, first of all, to bind the bones together. That's universal. But second of all, to enable movement, and the amount of movement and the class of movement is variable, as we'll discuss today. So we can classify joints in all different ways. One way is by the architecture, how they're made. So fibrous joints are joints that are connected together by fibrous connective tissue, hence the name, and there's no joint cavity. We're going to talk about joint cavities in a minute, but the most flexible joints have a cavity that's like a very elaborate joint that has lubricants in it that allows a lot of low resistance, a lot of flexibility, where a fibrous joint is not in that group. A cartilaginous joint, again, doesn't have any cavity or synovial fluid chamber. It does, the two structures are connected, but instead of by connective tissue that's fibrous, they're joined by cartilage. And finally, the other architectural classification is the most flexible of joints. There's a synovial, we call it cavity, that contains fluid, and it also has some articular cartilage that's part of the joint, and often there's all kinds of accessory ligaments and other structures, as we'll discuss. We can also classify joints by how much movement or functional classification. So the one with the least movement we call synarthrosis, which essentially is a synthesis is something that's brought together. So that the prefix SYN means conjunction or brought together. And so it's actually just two bones connected together with no movement, synarthrosis. And structure-wise, it's two bones with a very thin layer of regular connective tissue between them. And the suture is a very good example of a synarthrosis. There's two bones have grown together, and they're actually glued together by connective tissue. So there's really no flexibility, as I said before. as in coronal suture. Another type of synarthrosis is a gumphosis, which is a very specific articulation in which a tooth fits into a cone-shaped hole or socket. So again, very, very little movement, essentially some connective tissue between the two structures, the root of the tooth in the socket, and what the connective tissue there is called a periodontal ligament. So this is an example of gumphosis, and both of these, suture and gumphosis, are examples of synarthrosis. The next type of synarthrosis is a synchondrosis, and the term chondrosis refers to cartilage. So it's two bones connected through cartilage, and a good example of that is we mentioned last time, the epiphyseal plate that's up in this area of a long bone. So actually the bones are connected at that epiphyseal plate. Also, the ribs articulate with the sternum, and the only thing between them is cartilage. So a synchondrosis is when two bones are connected, extremely little bit of motion, if any, by a cartilage plate. And then we move to the next level of arthritic connection, which is a little bit of movement. Definitely not a syndesmosis. It's called an amphiarthrosis, a little bit of movement. And in this case, an example would be the distal joint between the radius and ulna, where it's like you've taken those two bones and wrapped the rope around as tight as possible. So there can be some movement between the two bones, but very little. And so it's fibrous connective tissue, which is essentially like a rope that's tied between the distal part of the ulna and radius to hook them together, so it allows some flexibility between the two. And a symphysis is another good example of this amphiarthrosis, and that's when you have a pad of kind of sponge-like cartilage between two bones. And the pubic symphysis, we were going through the structure of the os coxal bone last time, and I showed you the little pad of cartilage that's between the ventral part of that bone, the two bones, and that's the pubic symphysis right here. So it's a pad of cartilage between two bones. So there is a little bit of movement at the os coxal bone articulation. And finally, diarthrosis means it's essentially two bones that are free to move by some sort of mechanism. And generally, we'll go through some structures that usually are present in these diarthrosis and then classify them into groups. But they're usually surrounded by a dense, regular connective tissue that surrounds the whole area that holds the bones together. So the bones are held together by this joint capsule that surrounds it. And then within the capsule is a membrane lining, which here is kind of a red color, you can see. And it secretes a fluid called synovial fluid. And this lubricates the joint and nourishes the cartilage cells and so forth. And along with some other ancillary structures, it helps cushion the joint, so if you jump up and down on a trampoline, you don't crash the two bones together. And we have other structures that do the same thing. One of the most strong is a meniscus, and here's a figure right here of a meniscus and another one over here, and they subdivide the cavity. It's essentially a cartilage structure that's between the two bones, so when you again jump up and down the cartilage, the raw bones aren't hitting each other together if you jump on a trampoline. And also often there's a fat pad that does a little bit of the same activity as a meniscus, but not near as, has much less tensile strength. Also does some distribution of weight as you're standing on your legs or supporting something. Besides the joint capsule, the bones are held together by straps of a regular connective tissue that goes from one bone to another that are called ligaments that interconnect the bone. So there's a capsule around the whole structure, but then bands of regular connective tissue that's like ropes that tie the bones together. And depending on the type of joint, these can be quite complex. And a third structure is bursae, and there's a couple of bursae indicated here. There's one on top of the patella right here. Often bursae are between bones and ligaments, so the patellar ligament has a bursa both on top of it and underneath it. And these are fluid-filled bags that help cushion or reduce the friction between two structures. It's amazing how these things have evolved. We have these little bursa that protect the ligaments from bend or from friction as the two structures move past each other. You've probably heard of the term bursitis, and that's when these bursa get infected and inflamed, and they swell and cause a lot of pain. That is an infection involved by the structure of the bursae. So these nice table that summarizes the different groups of joints functionally, and also gives you some examples of each. Another way we classify synovial joints is by the type of motion that they're characterized by. So this is another functional classification, and it's looking at what type of motility or action is possible at a given joint. Some of these joints are like two flat surfaces rubbing together, and so they call it a gliding joint. It permits motion side to side, front to back. And an example of that is those irregular bones in the wrist, which we call carpals, and some essentially are two flat structures that articulate past each other. A second type of motility is what we think of mostly, I think, when we think of joints, and that's a hinge joint, which just like hinges of your on a door allow movement in a single plane. So this is a convex and a concave surface, and a good example is the joint between the humerus and the ulna, but it is essentially capable of movement, flexion and extension on one plane, movement in a single plane. The third type of movement is rotation, and we call it a pivot joint, and the best example, I guess, is the head turning in humans, and the head is this turning motion, and rotation is allowed. Again, I showed you this when we're going through the spinal cord, spinal column, is facilitated by the axis and atlas interaction. The atlas has a pin, essentially, which we call a dens or odontoid process, upon which the atlas rotates on, and so it's kind of a rotatable junction. The fourth is a condyloid, or what's also called an ellipsoidal joint, and it consists of an oval-type bone that sits in an elliptical cavity. And you can, once you get this picture, you can imagine what type of motion is allowed side to side or back and forth, as the arrows indicate. And this is only found in a couple very restricted places, and the most common is the proximal phalanges and head of the metacarpal. So this is the most proximal phalange and the end of the knuckle, or the palm, the metacarpal. And you can move your fingers and figure out what that is capable of, but it's called condyloid activity. And another kind of very restricted example of motility is the saddle joint. And the saddle is a nice descriptor of the mechanical characteristics. It's like a rider sitting in a saddle, and you can see it can turn back and forth or lean forward and backward. and the thumb is an example of that. The first metacarpal in the trapezium right here. So it's an example of this saddle joint. You can move your thumb around it and kind of demonstrate it. Ball and socket joint is one of the most flexible of all joints, and it's literally a ball on the end of a bone, or the head of a bone, that rotates in a receptacle, which we call the socket, and allows a little bit of rotation, but like a joystick on a computer, the ball, the structure hooked to the ball can move all types of motility, triaxial movement. And the hip and shoulder joints are both examples of this, and these are the two of the joints, that have great injury and expensive to repair. But here's the hip ball and socket, which is the head of the femur and the acetabulum joint that as we age, it often becomes more and more restricted and painful in movement. Cannot have an artificial joint implanted. Okay, another way we describe, and this is actually more useful than the classes, functional classes joints. As you go to a physician, often one part of the physical is they measure motility in various, or range of motion in various limbs, and they classify it by name. So these are the names which we often classify the varying motility in a limb. For example, flexion is a decrease in the angle. So here's flexion of the elbow. So you're decreasing the angle at the elbow, where extension is the opposite, extending the limb. Abduction and adduction refer to the movement of the appendice or appendix away from the core or the trunk of the body. So abduction is moving towards, or adduction is moving towards, and I always remember that by the word add. You're adding the arm to the body. So adduction is moving it towards, or abduction is moving the limb away from the body. Dorsiflexion is, if you think of the dorsal part of the foot, it's said you're flexing it, but the best way to remember it is dorsiflexion is extending. Looks like I have it backwards. Probably, yeah. Plantar flexion is extending the foot. It's backwards here, and you can see it on here. I think I changed it on your outline. Maybe I didn't change it here. So plantar flexion, just like it shows here, is extending the toes away from the foot, or extending the foot. And dorsiflexion is flexing the foot, moving it up towards the leg. So that these two terms should be exchanged. I think I did it on your outline. Circular movements, just a couple of examples. We talked about rotation of the head. Circumduction is a very complex term, which is circular movement of a limb, like this boy is doing, forms a cone-shaped face. So you're subscribing a cone when he moves his arm. Supination is, we're going to use this or see this later when we talk about muscles. In the group of muscles, there is in the elbow a supinator and a pronator. A supinator is the muscle that moves the forearm with the palm upward. So you're turning the forearm so the palm is upward. So this is the result of supination. And pronation is turning the arm so that the palm is downward. And we have a muscle that does each of those activities in the elbow. And finally, some other terms that describe movements in our body. Elevation, most of these are easy to to figure out. Elevation is raising limb, and you can think of the only thing, one of the few things that goes straight up in our body is our jaw. So you elevate the jaw or depress the jaw. Protraction is movement forward, and retraction is movement backward. We're going to talk about the temporomandibular joint. It's very flexible, but this is the jaw also can be moved forward or backward in order to chew our food. Eversion is a unique word that we use for our feet. When we evert them, we twist them so the sole is turned outward, as shown here, and inversion inward. And so that's the kind of an overall description of different types of movement, how flexible a joint is, and so forth, in the parts of the joint. What most texts do after this is give some examples of some joints and the type of motility that's characterized in the parts of the joint. I've picked a few of these to describe. I'm not going to have you learn all of the ligaments. There's a tremendous number of ligaments for each of these, and they do that in medical school. All I want you to do is know what's in the outline, the major structures as far as bones involved, and the type of motility that's capable. So the first one is a temporal mandibular joint, sometimes called TMJ. And you've probably heard people have TMJ afflictions. Some people, when they open and close their jaw, it clicks. So there's all kinds of problems involved. And part of the problem is that it's such a flexible structure. So it involves the mandibular condyle. So here's the mandible, and the condyle and mandible sits in a little process called the temporal fossa of the temporal bone. So this is the structure here, but it's a fairly loose joint, and there's ligaments around, but it allows both, protraction and retraction, and elevation and depression. So there's a lot of motility, and as we age, sometimes we stretch it so much that your jaw slips out of that condyle slips way out of that fossa, and the clicking is when it comes back into the fossa. So anyway, that's a joint that's often irritating to people. Temporal mandibular joint. The intervertebral discs are another often plague of many of us as humans achieved upright posture. We put a lot of stress on these cushions, these intervertebral discs between our vertebrae, and a tremendous fraction of us have these discs that become a serious problem as we age, and we end up with a lot of back pain. We'll talk about it more when we get to another section of the class, but each of these discs has a annulose fibrosus, which is a fibrous outer layer, and a nucleus pulposus, which is an inner gelatinous layer. And so they're not just a pad of cartilage, but they're complex in structure and can often be part of pathology. And we'll talk about it a little bit more later on. I mentioned the connection between the ribs, or between the clavicle and the manubrium in the last lecture. And this is a structure with more detail on that interaction. It's a gliding type joint in that the medial end of the clavicle slides back and forth on the sternum, but this gives you a little bit of representation of the structure of this gliding type joint. The glenohumeral joint is the ball and socket joint in your shoulder. And again, it's the glenoid cavity of the scapula, which is represented right here in the head of the humerus, and it's a ball and socket joint. The head, of course, can rotate in that socket. Its cavity completely envelops the joint. There's all kinds of ligaments that hold it in place. And bursa, nicely pictured here in these green sacs that, again, protect the ligaments from the abrasion from the bones and the structures surrounding them. So it's a very complex joint. It's no surprise that people often have shoulder pain during times of their life. The elbow joint is represented right here. It's the hinge joint, the classic hinge joint. So you have the trochlea, we call it, of the humerus, the proximal humerus, or the distal humerus, rotating in the, we call it capitulum of the radius, and the head of the ulna. So anyway, that's right here. It's a hinge joint, which means it's capable of flexion and extension. And again, there's a bursa represented, lots of ligaments and so forth. And finally, one one of the most complex of all joints is the hip joint, another one that gives us a lot of pathology as we age, another ball and socket joint, and it's the head of the femur and the acetabulum of the oscoxal bone. Lots of cartilage involved, covering the surfaces of both the acetabulum and the head of the femur. Wide variety of movement, and again, we'll see lots of involvement of this as we age with pain. And the knee joint, another hinge joint, but it involves two condyles. Condyles represented as medial and lateral of the femur, and then the tibia, the proximal of the tibia articulates with the femur. The femur and patella, the bone on the knee cap, is a gliding joint. So not only is it a hinge joint, but there's a gliding activity of the patella on the femur, and lots of bursa and lots of menisci and so forth also involved with this. But the joint itself only has flexion and extension possible, unless we play football, and then we create new positions for the joint to be in. Okay, so anyway, we won't worry about that. For this test, you can file all that away until we get ready for the second exam. So what I want to do now, with the time left, is go through the
End of lecture 8.
for my exams.